Um, I'm I'm
Hmm.
having some trouble with um, an error that I'm getting when I make my own IntelliJ project. And after
Can you
I,
show me? I'll just quickly fix and see. Have ready right now?
yes, I have it. I can show you.
Okay, I can make a presenter. Okay.
Okay, let me, okay.
Mm.
Um, I'm looking for the sharing my screen. I don't see it.
No, I have made you presenter. Yeah.
Okay,
Mm.
then let me, sh is it sharing right now?
Yes, yes, you
Or-
can share now.
Uh, share screen. Okay, I think it should be working right now.
Yes, yes, I'm able to see. Yeah.
Yeah, so I imported your project. So on here, I don't have any issues running
Mm.
of this copy file, for example.
Mm.
And I did the Maven dependency, the same on my own example. But for
Mm.
me, I'm getting this error here, which is no file stream scheme for HDFS.
Okay, so you're saying no file system is DFS.
Yes.
Okay, so okay, one second, I take the control. So,
Okay.
so your Hadoop is running, right? Your Hadoop is there. That is running.
Yeah. Yes, I can check right now, but if I remember, it should be running right now. Can I check real quick?
Okay, yeah.
Okay. Yes, it seems so. Yeah. Oh yeah, my services are on for Hadoop.
Error is no file system.
Yeah, and when I Googled it, it seems like most people are talking about either the Maven, how this is done. Also, just quick
Okay, so
question is
okay. So do you see right because maybe the version is the issue. Okay, so what version I was using? So you
you
is the version, right?
yes
Okay,
yes I saw your version. It was just 2.73. I tried the same, but I still had the issue.
same issue.
Um, yes. And then the second thing I saw online is people would say with this, having this configuration, can you check if this looks okay right now? This should be
Yeah.
my user
Yeah.
samples.
And
The port,
SDFS colon slash you are giving 9,000.
yes.
Okay, so this one. Okay, something like we can set in the Hadoop config, right? So here, okay, already you set the default. Okay, one
Yes.
property also there.
Mhm.
Actually, maybe what configuration dot set, because I found it somewhere, this property fs dot sdfs dot impl. Okay,
Mhm.
second value second value is org apache hadoop dot sdfs dot distributed file system dot class dot get name apache. Hadoop dot, here it is not taking the package. Hadoop dot, okay, SDFS package is not coming. Was it FS? Open file system dot class dot get name. So this property is fs dot file. Oh, sorry. Fs dot file. But one more property is to recognize SDFS.
Mhm.
So that one. So how many jar you are using? Client or common? You are
Just
using
I
common.
only have common.
Client also we use Hadoop client.
Okay.
Okay. So Hadoop client. So and one property is SDFS client also is there a jar SDFS client. Hadoop client, Hadoop SDFS client. Okay, now it recognized. Hey, that code is running, but maybe your and which Hadoop version? Same 3.3 you install.
Yes, that's the one I have
Okay, but
installed.
here is not a problem because yeah,
Mhm.
so here this is we are running through Java code.
Yeah, I tried both. I thought maybe it was the compiler, like but it didn't seem like that way.
Mhm.
But actually, no, this is okay. But here on this main one, I don't have the same configuration set that you just put in the other file.
Mine
But
one not is the same, right? Okay, this code is not a something is version, right? Like okay,
mhm,
maybe here is all, and one more jar also. Actually, one is a Hadoop client jar also. So let's see if this doesn't work. So one more jar Hadoop hyphen client. So one is we are using Hadoop as a hook. Let's see. I'm thinking like was because this issue I didn't face.
mhm.
Because if anybody tries, so we can easily know, right? If this issue is coming like because of the what version. Okay.
Hmm.
So I run the app.java, right? Oh, no, I run which file I run?
I think you ran app.
App.
Um,
Okay.
yeah, because app is the one that has Hello World.
Hello world, right? So, okay, one thing is why it is not coming the run main run. That
Yeah. I think at the top I have it. It's set
see,
as app
see,
right
see,
now.
see, this is what I think
Okay.
it's working, right?
Yeah, it looks like it worked now.
Okay, so only just I put it jar. Actually, even this property is also not needed. Only the relevant jar was not there, which is need the
Hmm.
Hadoop file system. Okay,
Okay.
right. SDFS client jar. Okay, now if
Okay.
we
Yeah, you had to change that.
yeah, actually in the top, this is the only one. Okay,
Yeah.
okay. Now, so it gives the error or not, right? Like because here in the Java program, it doesn't come like give the issue, right? Whenever we run,
Yeah.
it simply override. Oh, I wrong, right? Actually, I have to comment this one, not this one, because this one is needed.
Hmm.
Because this is the other one, which I added.
Right. So it's not any of the configuration setting you did in code, only the missing jar,
Only
right?
just jar, yeah, that dependency.
Okay.
So that file scheme is coming, right? So whenever any new right file system you are recognizing, right? Suppose you are writing to
Hmm.
the S3, okay? So you
Hmm.
should have the S3 related jar. If that jar is not there in your program, right? So you
Hmm.
will get that error, right? The FS scheme, like SDFS is not that is a protocol, right? The Hadoop file
Hmm.
system protocol, right? So that
Hmm.
is need. So that is not able to recognize because of the jar, right? That
Hmm.
protocol. Now you see that you're working, right? This code is working. Okay.
Yes.
So
Okay.
it is because of only that client jar, Hadoop SDFS client jar. Okay. If someone
Okay.
gets this problem, then he has to. Otherwise, I'm saying that code will work because if the same code is working for me, okay. So it is
Mm-hmm.
not needed. Okay.
Yeah.
Yeah. Okay.
Okay. Okay. Thank you.
Any other, anybody else? Okay. So you can just make unshare the screen.
Mm-hmm.
Otherwise, I will. Okay, I reclaim. Okay. So I think all the most of the people have joined. Okay. So yeah. So this kind of questions came, I just give you a heads up, okay, because you just get the idea. Just like three coding question were there, okay. One question was the count occurrences. It's very pretty simple question, right? Like you have a one string and you have a one character, okay. So need to find the character how many times in that string, okay. So it's very simple logic right here. And one use case was there, like if the string was upper lower case, right? So it will not match because the string will be the case sensitive, right? So we have to use the lower, right? So we have to make it lower both, right? So if you make it lowercase both, then it will match. Okay. So we will be iterating each character in the string, whatever input string is there, and we will check wherever the count is matching, and then we will do the count plus equal to one. It's very pretty simple questions, right? But some use case are there. Suppose this character, if I'm passing as a blank, okay. So in that case, my output comes zero, right? Because my character is not matching in the string, right? Like in this string. And other case is like if character is not matching at all, right? This k is not there, right? So in that case also output should come zero, right? So here that is because of the count is zero, because this count will not increment. So final count will be written zero in this k. But if the string is the character blank, right? This is so I'm checking here the character, right? I'm checking a blank and returning zero is straightforward, right? I don't need to run any loop. Okay. This is the question. Another question with the SQL queries related question. The SQL related question is the four tables are there, like employee, department, employee, project. Okay. So here we need to find the employees who have not any project. So right, this is like a left outer join where left side employee table there and right side is like a employee project table is there. So this department table is just joined for the getting the department name. Okay, so right, employee and department table both having a department ID is a common, right? Department ID, correct? Are you following me?
Yes, sir.
Hello?
Yes,
Okay.
yes.
Yes.
So what I'm saying here the four tables are there, but actual table, if you see the three tables are used. Okay. So one is an employee project, okay, and department table. So department is used just inner join for getting the department name. But the left join we are doing with the employee project because we have to find all employees, okay, and their right side table project ID is null. Those are the record which has the left side data but not right side data. If I don't use this one, it will give me all the record of the left, whether it's having project or not project. It doesn't matter, right? If I remove this condition, this is the condition only because of that I can find the employees who has no project. Okay. If you don't give this condition, even you are using left join, but it will bring you both because left side all data will come, whether right side matching or not matching. But when you give this condition, so here you are restricting your right side project ID is null, means where the project ID is populated from your left, that you are ignoring, right? So in that case, you will get the employees without project. Okay. So this is the one question. This is the tables, right? Employee, projects, department, and this question you will find in the lead code or some website. Okay, and this kind of one scenario question was there, like if the data, like some 550 GB data, right? This is like streaming pipeline question, right? If your data, you have to uh, like catch up the data, right? Like 10 hours, your pipeline is fail, right? And it's not run. And when you run the pipeline, so how can you catch up your 10 hours data? So there are the we have to do the memory resource driver executor memory. So we have to increase the configuration, right? So once we increase the Spark configuration parameters, right? So memory, driver, cores, executor, so it can impact and it will improve the performance. And one more question related to actually one Python, one SQL, and one Spark question was there. So that question is not there, but the question scenario was one transaction data is there, okay, one customer data. So we have to find transactions which are having $500 or $5,000. Okay. So first filter condition is this, and after that we have to do the purchase date, right? Like purchase date in the between the some particular date, right? So we have to do the group by on the aggregation. We have to do first before this filter. We have to do the transaction transaction data. We have to do group by on customer ID. Okay, so that we can get the total purchase amount. Get total purchase amount for each customer. Okay, so after this, what I will get it? I will get it for each customer. I will get it some purchase amount, and then I have to check which having 502 or 5,000, right? Like this kind of condition is there. Once after this filter is done, then I will join my customer data, because transaction data has customer ID, but customer information is not there, right? Customer ID, customer name, customer other information, right? So I will join my customer DF data frame data and get the final result. And this result I have to save. This result I have to save Parquet file format, that is a corner file format, Parquet file format with partition by purchase date. Like I want to know how many this purchase date, how many customers are there, those many data. So there will be separate file will be saved. Okay, and this code we have to write in the Spark Scala. Okay, so when this type of scenario questions are there, so first we are reading the data, right? We have a CSV file, JSON file, we are reading data. Then we are performing the group by operations, right? So it's similar to the in SQL, right? We do the group by clause, right? We use, okay. And then we use the we use the having clause, right? In the group by aggregation, right? We use the having clause, right, to check, right? Okay, so this is the exact code. Like first we are reading a customer data frame, we are reading a transaction data frame. Just it is, I'm just talking about, just showing you like what type of code we have to write in in front of the customer client. So we are just reading the data, transaction data. First we have done the group by on the customer ID, aggregate sum of the purchase amount, and we call it as a total purchase amount. And then filter we are applying, like if the transaction amount is either 500 or 5,000. Okay, so I should get all those transaction data. Okay, for those customer transaction data I will get it. Then I will do the join with the customer data frame, customer data. Then final result I'm writing as a partition by total purchase and saving as a Parquet file. So this is the Spark Scala code. If same code, write code in PySpark, okay? Because somewhere like they ask, you have to write only Python, PySpark. So in that case, your syntax will like val and where will not be there, okay? So you will simply writing like this part is the same, like a Spark session you are creating, customer DF you created, transaction DF is created. So if you understand the syntax of one, like Scala, then you can write the same syntax for the Python. So can you see here, the difference wise, the logic is same, like exactly the group by is there, aggregate sum is there, filter is there, like same conditions is there. And then we are doing the join on the customer ID, final result we are getting, and then final result df dot write dot partition by total purchase, and then Parquet file. So code wise, just a syntax is here. Here we don't use val and where. because in Scala code, we have the like a prefix is there, like val or where we have to define. But in the Python, we can directly write a variable, right? So we don't have any specific like a variable like a type we don't need to define. Okay. So this way we can write a code. So this was the PySpark or Scala code you can write. Okay. So these were the three questions to decide like the person is able to work or not, right? So this is the way. Okay. I will ping this all these questions in the notepad and I will save it in the classroom. Okay. So there you can see. Okay. So
Okay.
this is the scenario I told you. You should prepare this kind of SQL questions, Python logical questions, and some questions like Spark questions, like how can you prepare, right? This kind of questions. Okay. Anyone has any question? So first round is also more technical round, and second one is also technical, right? Coding round. So both are the 100% coding. Okay. So, so everybody's VM is Hadoop is running. Everything is like setup is done. Like anybody else, like still has not done the setup or any issue, because other people can help, right? So if anyone has issue, can discuss each other, right? And like solve the issue, right? Any installation related issue. Okay. So I will start today MapReduce concept. Okay, MapReduce mostly the theoretical fundamental concept, and I will show the word count program also, how we can write a MapReduce code. Okay, but we don't need to focus on the writing MapReduce code. We are our purpose to write just understand fundamentals of the architecture of the MapReduce, like what is a map, what is a reduce, how MapReduce works. Okay, so that you try to understand, and if you can write code. Okay, even if you copy paste code and run, that is good enough. And if you can explain anybody code, that is also fine. Or if you can just prepare three lines of code of both map and reduce, right? So that is also enough, right? Because sometimes some interviewers, they can ask, okay, write a map function, write a reduce function. They will not ask you the import statement, all those, okay? Because everybody knows, right? Nobody can write the all import and the class syntax, right? But at least logic syntax you can write. Okay. So if that part you are okay, is fine. MapReduce is good. Okay. Okay. So there is no more expectation in the MapReduce, right? You should be very well, right? Able to write 200 lines of code. So it is very difficult, right? Because MapReduce is like nobody can write the complete code in the interviewer, like in interview. So first I start with MapReduce fundamentals. Okay. Okay, so first we starting with the MapReduce. So basic things we know about like Hadoop, right? Hadoop architecture, right? We have seen there are the two core component, SDFS. So SDFS is the core component and MapReduce is the core component. Okay, so they are the two core component, SDFS and MapReduce. Okay, and when we say MapReduce, right? So MapReduce is for the again two core component, right? Job tracker and task tracker. A job tracker and task tracker we call in the Hadoop 1.x. Okay, but in Hadoop 2.x and 3.x, we have resource manager and node manager. Okay, the resource manager is master and node manager is slave, right? Which is performing actual task, and resource manager is allocating the resources to the node manager and talking to the name node to get the task, right, from the name node, right? Okay, and then allocate the task to the basically resource manager allocating task, but resource manager is finding like what exactly requirement of the client, right? Like whether he's looking for to read a file or write a file, right? Accordingly, it will allocate the task. Okay. So when we start the MapReduce, MapReduce is a Java-based framework. Okay, it's a Java-based framework, and there is the architecture of the MapReduce is map and reduce. Okay, so two core functions are there, map and reduce. So map is basically splitting the data. When we say map, right? So map is splitting data into various machines, okay, and process the data and process data. And one more thing is map is doing like, if I say like if I'm doing the word count program, so I want to write some logic. Okay, so general map function is just splitting data and process data. What logic you want to write, that's a different thing. And reduce function is basically aggregating data from the various machine, aggregating data from various machines, and get the final output. Okay, so if I just take a one example use case scenario, I say final output. So if I say I have a one text file, okay, test.txt file, and this test.txt file I have some data. I say, okay, hello. So I have a repeated data. I'm just doing the word count through MapReduce. Okay. So I'm just taking a very simple file. I have data like this is there in my text file. So first, like my MapReduce job, right? So in my MapReduce job, so here, like we have the three classes to implement. So three classes, like we are writing a Java code. Okay. So one class is called driver class. Another class is called mapper class. And third class is a reducer class. Okay. So driver class is the entry point, right? Driver is the entry point to start your program. You know, the main function, right? Wherever the main function is there, you can start that program. Okay. If you don't have the main function, you can't start. So driver is a class where you start a job. Like first you have a main function. Inside this main function, you are creating a job object. So job is a class, that is a API class like Hadoop API class, right? So job you are creating, a job instance you are creating, one job instance you are creating. And this job instance, you are setting what are the other classes you want to call from the driver, because driver is the entry point, but further your control is going to the mapper and reducer class. So like we can set mapper class, like method, we set the mapper class name. So we are telling here, what is my mapper class name? And in the job instance, I'm setting what is my reducer class. Okay, set reducer class. I will show you this code, but I'm showing you the skeleton, right? What is the skeleton of the structure of the code? Okay. And here I'm showing the reducer class name. So three different classes there. So driver class, I'm defining my job instance, and I'm defining the mapper class, reducer class, and I'm setting in the job, like in this, basically I'm setting a input format and output format. So input format is like whatever input format is like file I'm giving. So what type of format it is? So text, it is a text format. So text is a default format. There are other different format also there. Like nline input format is there, DB input is there. Like if I'm reading the data from database, so that is a DB input format. But this is a default format, text format. So this format is text format, text input format. So text input format is there. This is the text input format, text input, text input format. Okay, input format. So this is the format type is there. Same like a job dot set output format, because when I'm just creating an output file. So what will be the format type of that file? So that is output format. Okay, text output format, text output format. So these are the properties are there, and we are setting what is my input path. So job dot set input path, right? Basically, I want to set where is my input file is residing. So I'm giving a location of input file. Okay, input file location, input file, and same like job dot set output path. So output path, we are not giving the file, we are giving a directory location, because file naming convention will be decided by the mapreduce. Mapreduce is creating a map r hyphen 000, like that file naming convention will be there. So I'm giving a directory location, directory of output file location, output location. Okay, so like this we are setting the property, and then next is job dot set like a job for completion, wait for completion, wait for completion, and then like this method is there, and then finally we are exit, and then we are, this is our main function is ending. Okay, so we are writing this kind of code in the driver, and basically when I'm reading the file, so if the file is my test.txt, and I'm giving an input as a key value pair. So key value pair, I say in this file there is a position of the each line, right? I say this line is starting from the zero character. Okay, zero position, right? The first line. Second line is depending on the words are there, right? I define, okay, this is the position of this one is 0 comma line of text. This line of text, this particular line of text is my value. For this one is the value is like, if I say key, I say, okay, in this line is having 25 word. So I'm just defining the position. So this is called offset. This is called offset, basically the sequence position, because I have to pass as a key value pair. I have to pass the key value pair to the map function. Okay, so map function is taking a key value pair. So this key value pair is taking a key is a offset, and line of text is a value, right? This entire line. Okay, so basically this text file is divided into the number of machines, because just assume that like your file is very big, right? So one machine will not be handling the data, because we have a cluster, and cluster has a lot of machines are there. So the data is divided, so there is a different mapper machine are there, right? So wherever the map function is executed, this map function is there in the mapper class. So map function is there in the mapper class. So this mapper class machines are there, like different machines where the mapper class is running. So suppose I say 3 mapper machines are there, okay, where the data is, or two. Here assume it like 2 lines are there. The 2 mapper machines are there where my data is line by line distributed. Okay, one mapper machine. Okay, and second one is like I say, second one machine is a second mapper machine. So once my data is coming here in this mapper machine, and here is a map function. Okay, because in the mapper class we have map functions, like driver is having the main function, and mapper is having map function, and reducer is having reduce function. Okay, so we have to write this code. Okay, so in the map function, what I'm going to do, I'm reading this entire line of text and splitting into the word. See, word count problem is like we have to divide the line into words, right? Then I can count the word. Okay, this is the one word, this is the second word, this is the third word, this is the fourth. So, and then still I know, right, this word is in here also, but here I cannot do the counting. So that part will be done in the reducer. So for each parallel, every mapper machine is doing its own data. Each word you are giving one count. So what this mapper will be returning, this map function will be returning hello comma 1, because it's a one word. Hi comma 1, it is a one word. How, one word, because every word is a one only, because there is no counting, right? Because here I'm saying even hello is coming 2 times here. So I will not say hello comma 2, because our logic is every word is a one count. That's the logic is there. Okay. And I will tell about how can make it if this hello is coming more than one time. So why we write hello comma 1, hello comma 1. In that case, we can use some additional like class, right? Combiner, we will call it combiner. That is called mini reducer. So if that class, if I use the combiner I use, what it will do in the same mapper machine, it will combine the data. But Abhi, right now I'm not using the combiner. Okay, I will show you that code. But initially I'm just assuming it, if hello is coming 2 times also, every hello is given 1 count, or hi, any word is there, all word, how many number of words are there, those many number of time 1 count will be there. Same thing will happen in the second mapper also. So these mappers are individually are doing every word is 1 count. So that is the part of the this mapper class. The logic in the mapper class is take a line of text, split the line by space, and get each word 1 count. So this is I'm telling you in theoretically, but we have to write a Java code for that. It's just a 3 lines of code. Okay. So once I've done this, next thing is in the map reduce process, we have shuffle and sort. So I didn't tell about there is any class is not there. For shuffle and sort, it is done by the map reduce. That is not our job. Our job is to write a 2 classes, 3 classes, driver, mapper, and reducer. So next thing is once this line of text is splitted into the word and each word is given 1 count, after that shuffle and sort process is applied commonly, not only for one mapper. It is applied commonly. So what is the purpose of this shuffle and sort? The shuffle and sort is basically aggregate, it's finding the same key together, bring it together, and then after sorting. So after this shuffle and sort, what will happen? This how will come 1 comma 1 comma 1 3 times, right? And hi, how many times? 1 comma 1. How? 1 comma 1. Okay. But still we have another thing it has to do, sorting also done. So as per the sorting, which should come first? In this all, R will come first. So R will come after the sorting, right? 1 comma 1. Okay. And after R, which will come? So HE will come, then HI will come, then HO will come, right? Because this is the sorting order, right? So I'm just assuming that HE, okay, then HI and HO. Okay, like this, I'm getting the words. Okay, so shuffle and sort process, what is done? It is basically taking from every mapper machine data and doing the shuffling process. Why this shuffling is required? If we don't do this shuffling, right? So how can we bring together same key? Because we know, right, what count program we are doing. How many times is hello is there? So it is like, if you look at this one, you know the answer. But how MapReduce will be doing for the large amount of data, right? Because the simple data you can check and see, right? But suppose I give you one GB file, can you do manually? Like, because for this we need to make a process, right? We need to make some distributed processing process, and that is called MapReduce. So MapReduce, like 3-step process. Like first is a map function, which is splitting the data and giving each word is a 1 count. Then shuffle and sort process, that is done by the MapReduce because it is not in our control, because it is doing getting the same key together and bring the count. Okay, but still it's not doing the actual count. It is not doing. It is just bringing the data together. The actual count will be done by the reducer. So what reducer will do? What reducer will do? It will take each key. What reducer will do? So here I'm just assuming my reducer is here. So what reducer will do? It will take each key and do the total count. So hello, first one is a R. So R is there. So what R? R comma 2. Hello, comma 3. Hi, comma 2. How, comma 2. So like this, like this it is doing, right? How, comma 2. Okay. So the final word count is what? This is the final word count or not, right? This is the final word count, right? Output. And this data will be written into the output text file. So how many steps are there? Total 3 stages are there. When the first stage is we are getting a key value pair as a offset is my key and value is the line of text. Again, after the map, right, the shuffle and sort also taking a key value pair. This is also key value pair. But what is the key and what is the value here? If I say here is a key for the shuffle and sort is key is my word, right? So text key is a word, right? The text and value I will say it is taking a count, okay? And if I say so here is integer, it is now changed, right? Here is a key was integer as a offset, value is a line of text, but here is change. But again, after this mapper, this shuffle and sort, when reducer will accept again key and value. So, but here is a key and value. What is the difference? So, what is a key and list of count count values, right? 1 1 1 1 1 like that. Okay. And when the reducer is giving output, that is also key value pair. So, if you see here, this key value pair, when this key value pair, so this key value pair is again key is a word, key value, and the key is a word and count is an integer, right? Value is a count, right? That is an integer count. Okay. So everything in the mapreduce is flowing key value, key value, key value pair, right? Okay. So here the difference is here initially we are giving line of text, right? Here is the first line. This is the second line, right? So different mapper machines is processing the data parallelly. And one more thing is there, this mapper is not completed, the shuffle and sort will not start. Because suppose I say this particular mapper has very small line, but the another one mapper, suppose I say one mapper has very big line, okay, like big data, right? Like this big data is there, like long data. So definitely it will take more time, right? But the condition is the shuffle and sort process will not start unless all the mappers are done. Otherwise, what will happen, right? One mapper is completed and we started shuffle and sort. So it will be conflict, right? Our data will not be calculated correctly. So that is the rule is there when the all mapper is completed 100%. You will see the MapReduce job. The 100% is completed when the map is completed 100%. So initially it will be look like this. Okay, like this. Like map is 0. So initially map is 0%. Map is 0% and reduce is 0%. Okay. Now next is map will become 100%. Okay. But still 100%, but still the reduce is 0% because reduce is not started yet. Okay. 0%. But the last one is map 100. Okay. Map 100 and reduce 100. So like this, it's you will see in your processing, you will see the data is processing like this. So you can easily understand, okay, now till so far map is completed done. Now reduce is going to start. Now map and reduce completely done. Now your final output will come. Okay. Okay. So the same thing will understand through the program. Okay.
I have a quick question
Yeah.
for
Yeah.
that. In that process bar, is there a way to see the shuffle and sort? Will it be a part of either of those, or is it not included there? Is it a part of map?
Which one you said?
The shuffle and sort, you said, we don't code that, but that's a process that happens. Um, if map is at 99%, is that something like you could think that shuffle and sorting is happening, or does it not
No,
show
no, no.
in
99% means that still it's like completing the map, right? But
right?
sometimes this 99 means like one mapper is not
It's
completing.
still
That will be a resource taking or some issue, right? Okay.
okay.
So this kind of thing is called the long running job, right? So that
Mm-hmm.
we have to check our resources, okay? But
Right.
shuffle and sort will not start till the map is complete because that's like condition, right? Because there is a
Mm,
conflict, right? If I have not done completely, like I cannot go to the second section, right? This kind of
right.
exams are there, right? So
Right.
this is the same thing is here, because if
Right.
this contract is not being followed, right? So there's definitely the chances of the conflict, especially word count program, right? where you will be getting the result is different, right? Your expected output, right? Okay. So we have a contract, right? Our map is 100% completed. Then only your shuffle and sort. But shuffle and sort we don't see here. Actually, shuffle and sort between the, so it little bit take time, right? Between the
Yeah.
reducer to start. So you will
Yeah.
see little bit time it will take, because shuffling is just a shuffling process. Is means like just finding the same key and bring together.
And
That's
yes,
the
yes,
job.
yeah,
Okay.
yeah.
But actual reducer you will see here, you will not see anytime shuffle, because that is not
Okay.
our process. That is not our process.
Yes. Yeah, that's what I was wondering is if it ever is taking for some reason a lot more
Taking
time
time, so
for
that will
shuffling and
be an
sort.
issue in your job. Okay, we have to rectify that, because sometimes the 99% means that will be due to some resource allocation things, like at the last moment it's not getting some issue. So that is sometime become bottleneck or long running job, right? Because there could be any reason. Actually, there is a one concept is there, speculative execution. Okay. So speculative execution is very important in this scenario. What scenario you told, like 99% one. So speculative execution is basically it find if any thread is running slow. So it is allocating, right, to make it job faster, right? So it will create another thread that will make it execution faster, and like when the job completed, then it will be like removed, right, or will be destroyed, anything.
Yes.
So selective
Yes.
execution is a concept, like, but this property we have to make it enable, because we don't want every time to need it, right? Because otherwise it will be overhead, right? Unnecessary, right? If my job is running fine, so why I need speculative execution? This is the some special scenarios, right? Where I think, okay, if it will automatically, it will find automatically, it will find, okay, this is MapReduce framework will find automatically, right? If any thread is becoming delay or slow, so it will create another automatically find if any part of the program, part of the MapReduce job is getting slow. So it will create another thread to complete the task faster. Complete the task faster. Okay. I will give the definition, okay, that you can, but the idea is behind this speculative execution is like in the SDFS site.xml, you have to make it enable, right, true, right? By default is false. Okay. So that is the concept. Okay. So in
Okay.
the MapReduce, right, basically we have three different classes, right? I was talking about word count, driver class. Okay, so this is my driver class. So driver class, I've created a job object, which I talked about, right? Job is there, and job, I'm setting the mapper class. Combiner class I'm not using now. Okay, I just want to show without combiner. Okay, so combiner is having mapper side reducer. So if I say I want to make it more faster, right, my processing, and if the data is repeated, the condition is the data is repeated. Like suppose this hello is 10,000 time is there in the same mapper. So it is wasted, right? If I just write hello comma one, hello comma one, 10,000 time. Instead of that, if I use combiner, and I make it in the mapper side, hello comma 10,000. So this is better to go over the network rather than hello comma one 10,000 time is good, or hello comma one, hello comma 10,000 is better. So this hello comma 10,000 is better, right? So we aggregation process, which we do in the reducer, but reducer is doing the, still we need it. It doesn't mean like if we do this combiner, so our reducer is not it. Reducer is basically different mapper machine it is aggregating. But I'm talking about the same mapper machine. For the same mapper machine, we are using combiner. So combiner is used, and this is not extra class, right? Same like whatever your class, combiner is a class, is a reducer class. Whatever code you written in the reducer Java class, same code you can use in the combiner. The difference is combiner is a mapper side component, mapper side. Okay. And the reducer is the reduce side. Okay. So reducer is still is needed, but mapper combiner is just giving a one additional benefit for the performance. like if your data is most highly repeated time is there. So you don't need to give more overhead to the reducer. So you are just now making it for the same mapper. You will not be giving repeated data. For other mapper, it will be fine, right? Because this mapper on this mapper, definitely it's a repeated only that you can't combine, right? Before reducer. So that will be done by the reducer. But in the one mapper itself, in the map function itself, there you can call combiner. Okay. So first, before, after the mapper, after the map function, here the combiner will come in picture. Okay. So we right now here we just combiner will make it commented, and another one component is their partitioner. So I will tell about what this partitioner and combiner does. Okay. So simply I'm just creating a job instance. I'm setting a mapper class, reducer class, and output key class. So I told you, right, there is a output format and input format type like we defined for the. So this is my output, final output type. So here in the Hadoop, there is its own data type. Like, right, in the Java, we know string is there, integer is there, float is there. So here in Hadoop is the writable type. So text is a same like a string. It's a like equivalent to string, equivalent to string. There's a text. So equivalent text is a string. But there are the other type are there, right? Int writable. So int writable is equivalent to the int. The difference in the int or int writable, the int writable is a serializable type. So what is serializable type? Serializable type is like when the data is transferred over the network, right? Because in the mapreduce job, the data is always transferred over the network, right? From mapper machine to shuffle and sort, reducer machine, right? So this data should be serializable. So data serializability means, so when you are saving some data in one machine, same data can be deserialized. That's a Java concept like serialization, deserialization. Python also having serialization, deserialization. It's a common concept, right? Saving the object in one machine and getting the object by deserialization. Okay. Okay. So this one is writable is there. So we are final writing we are doing. That is the reason it's a serializable type. Like text is a string type, key. That is my key value count, right? So this is a key and this is a value. Okay, integer. And this is the input and output path, right? So input output path, I told two parameters we are giving. So one is an input path file and input output path directory. Okay. And the last one is our job will exit when it will complete its driver will go to the mapper will go to the reducer and again come back to the driver. So driver is my exit point. So entry point and exit point is a driver. Okay, because driver will start the program and driver will finish the program. So when your all the processing is done, right, you will come back to the driver, and if your job is completed successfully, you will return 0. Otherwise, you will fail. Suppose somewhere reducer is fail, so you will return the 1. You will get the 1 code. If you're completely successfully done all the phases, so your success code will be written 0. System.exit 0 means successfully written. Okay. When you come to the mapper class, so mapper class, this is the line of code we have to use. That's it. This line of code you have to remember. So here in this code, I'm just passing in the map function 3 parameter. One is a key, one is a text as a input value, and this is a context. So context is a variable which is sharing the data. Now you think, okay, what is the mapper is sharing data, how reducer will be getting through this context. So whatever you write in the mapper class, right, mapper execution, right, you write in the context, the same thing you will get in the shuffle and sort. Shuffle and sort will be writing on the context, you will get in the reducer. So context is like a one common shared variable, like something we can say like something is a common, right? Everyone can use it, right? If something is not common, if it is a private, like I can use only, right? But if something I make it common, right? So this is the common thing, like context. So that is the reason your data is sharing across the machine by this context. So whatever you write in the context, it will be received because it's a your all system are shareable, right? You already know, right? Because your complete infrastructure in the Hadoop cluster is shareable, right? So whatever is in one machine can be shared the other machine. But who is taking care of this? Hadoop is doing. You are not taking care of this, like how data will be shared. Just you are writing your program. You are writing your code, you are executing your code. After that, MapReduce is doing internally everything. And finally, you are getting a result as a output. Okay. So the main part is like, see, like you write any Java program. So you don't know, right, how internally Java program is running. There is a byte code is generating, then it is executing the bytecode, classes, it's running, right? But we are not bothered about that. We are just writing our Java code, hello world program, and I'm able to see my output, right? The same thing is here. I'm writing my MapReduce program. I'm executing my MapReduce program and I'm able to see output, okay? So when I'm reading a key, so here what I'm doing, this key is nothing but your offset. What offset I was talking about, this is the key, because map is taking the key and input is here the value, and this value is a text of line. I told you we will be splitting the line with the spaces, right? Okay, so this space is there and we will get the array. So how many words are there in my first line? 5 words are there. So how many times my loop will run? 5 times. So 5 times this loop, what it will do, it will take your this word, this S, right? I'm converting into the again text type, because when I'm writing the data from the map function, I will be writing into the context as a serializable. So I'm making my string type data. This is my string, Java string. So I'm making is a text type. And my count value, I told you that each value we will be giving one count. So I'm doing new int writable 1. This 1 is a primitive number like Java integer value, but I have to make it int writable type. So once I have written this data, so my reducer, what my reducer is doing, so reducer is the shuffle and sort process internally done. Okay. Now reducer is getting the key as a word, right? And list of values. So list of values is like 1 comma 1 comma 1. And what type of values are there? Int writable type, right? Integer type values. So you know, right, when the data will come to the reducer, what type of format the data will come? Definitely int writable type will come, right? Because it is coming from the context, right? So when you are reading data from context, so definitely you have to convert into the integer type, our Java type. So there is a get function is there. So whenever you are iterating data, int writable data, you are iterating for loop, and you are getting the value, each value you are getting and doing the sum. So how many time one came? Suppose for hello 3 time one came. So how many time this will run? 3 times. So 0, it will become 1, then 2, then 3. The final number will become 3. And this 3, you are again making what type? Int writable, because you are writing in the context, right? And the key is already text type. So you don't need to convert as a new text, right? And this output, you are writing into the output file. Okay, so 3 classes are there. Word count job, this is a driver class. Word count mapper, this is a mapper class. There are other functions are there, but this code is good enough to run. Okay, this code is main code. And the reducer class is this code. So whatever you have to remember, this logic you have to remember. In the mapper, what logic you have to remember? Just these 3 lines of code you have to remember. Okay, so how to run this program? So when you go to the edit configuration and you check like this is my, I'm giving this is my word count job driver class. Okay, and this is my input and output path. You remember, right? I have to give 2 path, right? So this is my xyz file. Some file is there in my test1 directory, and I'm creating a new directory in the test1. So you remember, right? We have to create always the new directory because it will always need a new directory. So I'm creating a new directory. So first we check this test1 directory. Okay, this test1 directory, I have a file xyz. This is the file I'm reading, and I have already created output 1, 2. So either I should delete a directory or I should change the directory name. So, okay, now I don't need to delete. I can use it same output 1, 2. Okay, so when I okay and I run the program, just right click the run the Java class. This is Java class I'm running because this is a main function in the driver. So this one is, you remember, right? I have given here word count job. This class I'm running, right? Driver class. So my code is completed. My output has come because this exit code is 0. So when I go to my output 1, 2, this is the output file. Can you see this output file? The result, this is the result. So you can say, right, these many number of time count this word is there. If I show you the XYZ file, this is my XYZ file. Okay, if I show you in this input file, okay, I just add this Germany word 2 more time. Okay, just I want to show you if I'm doing change, I saved it, I saved the file, and now I'm running my mapreduce job again, but I change the directory output 1.4. Okay, and I'm running it again. Okay, my code is completed. Okay, and now output 4.1 is created. Now I'm opening my output file. What was my last one? Germany I increased, right? It is coming 314. What was the last one? Last one was the
312.
Germany was the 312. So 2 increment, right? If you see in this one or this one, what is the difference? Everything is same because I didn't change any word except, right, Germany I added 2 more time. Can you see? Only this one is changed in this or this, right? So it means our code is working, right? And this many number of words, right, it count. If this one, if you use combiner, how fast it will be? Because I repeated these many number of times word, right? If you see, these are all repeated word only, right? The 3 lines are repeated 16,000 times. Okay, this one, because the 3 lines are repeated again and again and again, same, right? So if I use combiner, so simply what I will do, I will change in my driver class. In my driver class, I will allow the combiner. So same reducer code I will allow. And here, even in this one, I don't need to delete the directory because I put a 1 line of code that is making my delete the directory and create a new directory. So even if I don't delete, it will work if because of this line. Okay, if this line you remove it, you will get the error output directory already exists. Okay, so if I run this code again, I didn't change the directory. Okay, still the output will come in the same output 1.4. But output will be same. Can you see a little bit difference, like faster? Because already it is like if you try multiple times. Okay, now just some fractions times, like if the data is really very huge, right, then you will see very big difference. Okay, right? So output will be nothing change. Output will be the same. If I open this output 1.4, it is saying to again load the data. Okay, because my file is opened already. So I'm reloading file, but there is nothing change. Output wise, everything is same. Okay. Only difference is you will get it like data faster with the combiner. Help of combiner, it is making it more faster because it's applying the mini reducer, right? So combiner is basically the same class as the reducer class. So whatever you are doing the reducer side from the different machine, so combiner is doing for the same machine, the same job, right? For the same machine, it is aggregating. Okay. Okay, I'll share the program. The same code is there. If you have already this project, you can run this code. You have already this code. Okay, try this code, and I will share this the notes and everything. Okay, and the video. Okay, so you can follow and just try to run. Are you able to run or not? It's a very simple program. Okay, so I will tell tomorrow some more variation like this partitioner thing. Okay, and if you want to follow, you can see my previous classroom videos link. Okay, you want to check like something like I'm telling today, right? Partitioner, right? So you can understand, at least you can go through and think about it, like what is that, right? So similar thing you can do. Okay. Okay, thanks everyone. Okay, so tomorrow will be the same time. Okay,
Okay.
yeah, 7 o'clock. Okay. Yeah, thank you.
Okay. Bye.
Thank you. Thank you, Arvind.
Thanks, Arvind.